Do you remember the property of 30 degree, 60 degree, 90 degree triangle? Let's revise. Property of 30 degree, 60 degree, 90 degree triangle. If a triangle has angles measuring 30 degree, 60 degree and 90 degree, then the side opposite the 30 degree angle is half the hypotenuse and the side opposite the 60 degree angle is square root of 3 upon 2 times the hypotenuse. Using this property, let us derive the trigonometric ratios for 30 degree and 60 degree angles. Observe this figure. Triangle ABC is a right angled triangle where angle A is equal to 60 degree, angle B is equal to 90 degree and angle C is equal to 30 degree. Let AB is equal to x. Now AB is equal to half of AC because it is the property of a 30 degree, 60 degree, 90 degree triangle. Therefore, x is equal to half of AC. Therefore, AC is equal to 2x. Also, BC is equal to square root of 3 upon 2 times AC is equal to square root of 3 upon 2 times 2x is equal to square root of 3 times x. Therefore, in the right angled triangle ABC, AB is equal to x, BC is equal to square root of 3 times x and AC is equal to 2x. Now, let us derive the trigonometric ratios for angle C, that is the 30 degree angle. Therefore, sin C is equal to sin 30 degree is equal to opposite side of angle C upon hypotenuse is equal to AB upon AC is equal to x upon 2x is equal to 1 upon 2. Cos C is equal to cos 30 degree is equal to adjacent side of angle C upon hypotenuse is equal to BC upon AC is equal to square root of 3 times x upon 2x is equal to square root of 3 upon 2. Tan C is equal to tan 30 degree is equal to opposite side of angle C upon adjacent side of angle C is equal to AB upon BC equal to x upon square root of 3 times x is equal to 1 upon square root of 3. Next, let us derive the trigonometric ratios for angle A, that is the 60 degree angle. Sin A, that is sin 60 degree is equal to opposite side of angle A upon hypotenuse is equal to BC upon AC is equal to square root of 3 times x upon 2x equal to square root of 3 upon 2. Cos A is equal to cos 60 degree is equal to adjacent side of angle A upon hypotenuse, that is AB upon AC equal to x upon 2x is equal to 1 upon 2. Tan A is equal to tan 60 degree is equal to opposite side of angle A upon adjacent side of angle A, that is BC upon AB. Therefore, square root of 3 times x upon x gives us square root of 3. Now, let's find the trigonometric ratios for a 45 degree angle. Now, look at this triangle. Triangle PQR is a right angled triangle where angle Q is 90 degree, angle P is 45 degree and angle R is 45 degree. Triangle PQR is an isosceles right angled triangle. Let PQ equal to x, therefore QR is equal to x. Now to find the length of the hypotenuse PR, we will use the Pythagorean theorem. Therefore, PQ square plus QR square is equal to PR square. Therefore, x square plus x square is equal to PR square. Therefore, 2 times x square is equal to PR square. Therefore, PR is equal to square root of 2 times x square is equal to square root of 2 times x. Therefore, PR is equal to square root of 2 times x. Now, for angle R, that is the 45 degree angle, sin R, that is sin 45 degree is equal to opposite side of angle R upon hypotenuse equal to PQ upon PR equal to x upon square root of 2 times x gives us 1 upon square root of 2. Cos R, that is cos 45 degree, equal to adjacent side of angle R upon hypotenuse equal to QR upon PR equal to x upon square root of 2 times x gives us 1 upon square root of 2. Tan R equal to tan 45 degree, that is opposite side of angle R upon adjacent side of angle R, that is PQ upon QR equal to x upon x equal to 1. Therefore, tan 45 degree equal to 1, sin 45 degree equal to 1 upon square root of 2, cos 45 degree equal to 1 upon square root of 2, tan 45 degree equal to 1. Now, let us find the trigonometric ratios for 0 degree and 90 degree angles. Look at the following figure. Now, in this figure, triangle PQR is a right angled triangle. Angle Q 90 degree, angle R 30 degree and angle P 60 degree. Sin 30 degree is equal to PQ upon PR. If we decrease the measure of angle R while keeping PR constant, observe how the length of PQ decreases. The side opposite to a smaller angle is shorter and the side opposite to larger angle is longer. As PQ decreases, sin theta also decreases. As the angle decreases to 0 degree, PQ shrinks and sin theta becomes 0. Therefore, sin 0 degree equal to PQ upon PR equal to 0 upon PR gives us 0. Therefore, sin 0 degree equal to 0. Now, what happens if we increase the measure of angle R? When angle R equal to 90 degree, PQ equals PR. Sin 90 degree equal to PQ upon PR, that is PR upon PR gives us 1. Therefore, sin 90 degrees is equal to 1. We have studied trigonometric ratios for complementary angles such as 0 degree and 90 degree because 0 degree plus 90 degree is equal to 90 degree. Sin theta is equal to cos of 90 minus theta and cos theta is equal to sin of 90 minus theta. Therefore, cos of 0 degree is equal to sin of 90 minus 0 degree, which gives us sin 90 degree equal to 1. And cos 90 degree is equal to sin of 90 minus 90 degrees, that gives us sin of 0 degree, which is 0. Therefore, cos 0 degree is equal to 1, cos 90 degree is equal to 0. We also know that tan theta is equal to sin theta upon cos theta. Therefore, tan 0 degree is equal to sin 0 upon cos 0, that is 0 upon 1, which gives us 0. Tan 90 degree is equal to sin 90 upon cos 90, that is 1 upon 0. Since division by 0 is undefined, tan 90 degree is undefined. Examples. Simplify the following. Sin 45 degree into sin 0 degree plus cos 90 degree minus cos 45 degree into sin 30 degree plus cos 60 degree. Solution. Sin 45 degree into sin 0 degree plus cos 90 degree minus cos 45 degree into sin 30 degree plus cos 60 degree equal to 1 upon square root of 2 into 0 plus 0 minus 1 upon square root of 2 into 1 upon 2 plus 1 upon 2 equal to 1 upon square root of 2 into 0 minus 1 upon square root of 2 into 1 equal to 0 minus 1 upon square root of 2 equal to minus 1 upon square root of 2. Now look at the adjacent figure. In the right angle triangle LMN, angle M is 90 degree, LM 9 units, MN 12 units. Find the values of sin L, tan L, cos N and tan N. Solution. In triangle LMN, angle M is 90 degree. Therefore, LN is the hypotenuse. Given LM is 9 units and MN is 12 units, we will use the Pythagorean theorem to find the length of LN. LM square plus MN square is equal to LN square. Therefore, 9 square plus 12 square is equal to LN square. Therefore, 81 plus 144 is equal to LN square. Therefore, LN square is equal to 225. Therefore, LN is equal to square root of 225, which gives us LN equal to 15 units. Finding the trigonometric ratios. For angle L, sin L is equal to opposite side of angle L upon hypotenuse, that is MN upon LN, equal to 12 upon 15, which gives us 4 upon 5. Tan L is equal to opposite side of angle L upon adjacent side of angle L, equal to MN upon LM, equal to 12 upon 9, which gives us 4 upon 3. For angle N, cos N equal to adjacent side of angle N upon hypotenuse, equal to MN upon LN, equal to 12 upon 15, which gives us 4 upon 5. Tan N equal to opposite side of angle N upon adjacent side of angle N, equal to LM upon MN, equal to 9 upon 12, equal to 3 upon 4. We have learned about sine, cosine and tangent trigonometric ratios. Today, we will learn an important equation in trigonometry. Look at this diagram. Triangle ABC is a right angled triangle where angle B 90 degree, angle C equal to theta. Therefore, sin theta equal to AB upon AC. Statement 1. Cos theta equal to BC upon AC. Statement 2. Using Pythagoras theorem, AB square plus BC square is equal to AC square. Third statement. Dividing each term of equation 3 by AC square, we get AB square upon AC square plus BC square upon AC square equal to AC square upon AC square. Therefore, square of AB upon AC plus square of BC upon AC is equal to 1. Therefore, square of sin theta plus square of cos theta is equal to 1. Square of sin theta is written as sin square theta and square of cos theta is written as cos square theta. Therefore, sin square theta plus cos square theta is equal to 1. The equation sin square theta plus cos square theta is equal to 1 is true for an angle of any measure. Therefore, this equation is called a fundamental identity in trigonometry. If cos theta is equal to 15 upon 17, find sin theta and tan theta. This example can be solved in two ways. First, let's use K method. In triangle ABC, angle B is 90 degree, angle C is theta. Let BC equal to 15K and AC is equal to 17K. Now, according to the Pythagorean theorem, AC square is equal to AB square plus BC square. Therefore, 17K square equal to AB square plus 15K square. Therefore, 289K square is equal to AB square plus 225K square. Therefore, AB square is equal to 289K square minus 225K square. Therefore, AB square is equal to 64K square. Therefore, AB is equal to 8K. Sin theta is equal to AB upon AC, that is 8K upon 17K, which gives us 8 upon 17. And tan theta equal to AB upon BC, that is 8K upon 15K equal to 8 upon 15. Now the second method, using the identity sin square theta plus cos square theta equal to 1. Therefore, sin square theta plus square of 15 upon 17 equal to 1. Therefore, sin square theta equal to 1 minus 225 upon 289. Therefore, sin square theta equal to 64 upon 289. Therefore, sin theta equal to 8 upon 17. Tan theta equal to sin theta upon cos theta equal to 8 upon 17 divided by 15 upon 17. Therefore, tan theta is equal to 8 upon 15. What did we learn? Trigonometric ratios for angles 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Angle measures and their ratios. Sin 0 degree 0, sin 30 degree 1 upon 2, sin 45 degree 1 upon root 2, sin 60 degree root 3 upon 2, sin 90 degree 1, cos 0 degree 1, cos 30 degree root 3 upon 2, cos 45 degree 1 upon root 2, cos 60 degree 1 upon 2, cos 90 degree 0, tan 30 degree 1 upon root 3, tan 45 degree 1, tan 60 degree root 3 upon 1, that is root 3, tan 90 degree unable to determine. Fundamental identity sin square theta plus cos square theta is equal to 1. Exercise: if tan theta is equal to 9 upon 40, find cos theta and sin theta. Verify that sin square theta plus cos square theta is equal to 1 for theta is equal to 45 degree and theta is equal to 60 degree. Calculate cos 0 degree plus sin 90 degree plus sin 30 degree plus cos 60 degree multiplied by tan 30 degree.